I'm Norman Wahlberger. This is part of a series of videos on the foundations of mathematics. And last time we introduced fractions and the basic arithmetical operations of addition and multiplication for fractions. Now we want to prove some of the basic laws that those operations satisfy. And they're exactly the same laws that apply for natural numbers. So here's the setup. We have P, Q, and R fractions, indicated by this notation. And we want to prove a number of laws, and the first two are the commutative and associative laws for addition. We want to prove that P plus Q equals Q plus P, that's the commutative law, and that P plus Q plus R equals P plus Q plus R. What we have to do is we have to relate these laws to the corresponding laws for natural numbers. So we suppose that P is equal to A over B, that Q is equal to C over D, and that R is equal to E over F, where A, B, C, D, E, and F are natural numbers, represented by this notation. And now let's have a look, say, at the first law. So look at P plus Q. So A over B plus C over D, and we have to remember what the definition of the sum is. It's AD plus BC. So AD plus BC over BD. That's how we define the sum of two fractions. On the other hand, Q plus P, we do it in the other way around. We get C times B plus D times A, all over D times B. Now, why are these two the same? Well, because from the laws of arithmetic for natural numbers, we know that AD equals DA. We know that BC equals CB. And we know that B times D is D times B. And so we can use the ordinary laws for arithmetic for natural numbers to conclude that this equals this, and that's our first law. Our second law is the associative law. So there is P plus Q plus R, first with P plus Q being summed together. So this quantity here is, by the definition of addition, AD plus BC over BD. And now we still have to add E over F. Now we have to use the law on this expression. So we get AD plus BC times F plus BD times E in the numerator over BD times F. The other side, we have P plus Q plus R. We have to do the Q plus R here first. So we write A over B plus. Now what's the sum here? C times F plus D times E all over D times F. And now we have to add those two fractions. We use the same rule again. It's A times DF plus B times this quantity all over the product of the denominators here. And now we have to stare at this quantity and this one here and ask why are they the same. Well, in the numerator we have here an ADF term, which is the same as that ADF term. We have a BCF term, which is the same as that BCF term. And we have a BD times E term, which is the same as that B times DE term. And the denominators of both are B times D times F. That proves the associative law for addition of fractions. Now there are a few more laws having to do with multiplication. There's the commutative law for multiplication, the associative law for multiplication, and the distributive law for combination of addition and multiplication. There's actually two distributive laws, but by commutativity we'll just deal with one of them. Alright, so let's have a look at this first one. Using the same notation as above, P times Q, there's A over B times C over D, equals AC over BD. While the other way around, it would be C over D times A over B. We would get CA over DB, and these are the same because AC equals CA, and because BD equals DB. So that's our commutative law. Alright, so now the distributive law. So we have A over B times C over D plus E over F. There's the A over B, we write it again. And now this quantity here is the sum of two fractions, there's the rule for that. Now the rule for multiplying this fraction by this fraction, we multiply the numerators, we multiply the denominators. On the other hand, the other side is P times Q plus P times R. So A over B times C over D plus A over B times E over F. This product is AC over BD. This product is AE over BF. Multiply both of these by F, both of these by D, then we get common denominator, and then when we rearrange, we get this thing here. So ACF plus ADE over BDF, and we see that's the same as what we started with there. That's the distributive law for fractions. So we have gone from the natural numbers to fractions. That's a very big step, and we've checked that our basic operations satisfy the laws that we want them to satisfy. Now we're going to have to make another equally important step, one that was more problematic historically. The step from going from natural numbers to integers, where we introduce negative numbers. That was a difficult step conceptually, and we'll introduce the integers in a relatively simple natural way which mimics the way we introduced fractions. I hope you'll join me for that. I'm Norman Wahlberger. Thanks for listening.